Hello, everybody. Welcome. Are you having a good TDX? I certainly am. Hope you are, too. My name is Philippe Ozil, and today I'm going to talk about the 4 streaming APIs. I'm going to give you a bit of a tour about what these APIs are, and I'm going to tell you also what is new in the summer release. So to start with, this is a sales presentation, so I have to give you the forward-looking statement. Some of the things that I'm going to cover in my presentation are actually roadmap elements, so you should not make your buying decisions based on what I'm going to say. This is forward-looking statement. It may come in the product, or it may as well be cancelled. I'm fairly confident it will make it. So today, we are going to see 3 things. I'm going to talk about the 4 streaming APIs. I'm going to describe what these are, and I'm going to compare them, explain a bit what they share in common, and what are also use cases for those. Then I'll jump into the new things that will come in summer 19, and I'll finish with a small demo and some tooling how to play with streaming APIs. So to start with, does any of you know the 4 streaming APIs? Did you even know there were 4? Can you raise your hand? At least 1, 2. So not so many people, actually. And the reason is the naming is a bit complicated. We tend to use this word streaming API for a lot of different things. And the number of APIs that are grouped under this family of streaming API has increased over time. So I'm going to give you a presentation on what these are. These are the 4 streaming APIs. So it started from generic to PushTopic to platform events to the most recent one, which is change data capture. Now, most of my presentation is going to focus on the ones that I considered as current. This is not an official term, but this is where we spend most of our energy in innovation. We are working nowadays on platform events and change data capture. Why is that? Well, I'm going to tell you more about this, but this is basically, they can do the same things as the legacy ones, plus more. So, what are these streaming APIs? What do they share in common? They actually share a lot in common because they're all based on a single technology. All of that is built on a technology called Comedy, and this works with a publish-subscribe model or event-driven model. I will show that just in the next slide, explain a bit how this kind of model works. You can consider that also as push notifications. This is something that gets sent from the server to the client without the client constantly looking for updates. And this also has an interesting capability. It has a replay capability. So if you miss some events, you can actually rewind and replay past events on a certain window because it's not saved in database. What are those streaming APIs good for? They're good to 2 main use cases. System integrations, being external systems like web services, or even devices. You can actually control devices with platform events. And I'm actually hosting a demo booth upstairs that's called the Robotics Fridge. And you can see them in action, how we can control robots with those streaming APIs. Now, the other good use case for that is real-time notifications. Because this is push technology, you get updates to real-time. So if you have a user interface which requires real-time notifications, you can use streaming APIs to get those live updates on your user interfaces. Now, let's get into the architecture. All of those streaming APIs respect the publisher-subscriber model. At the middle of this architecture, we have the enterprise messaging bus. So this is part of the Salesforce platform. On one end, we have the event producer, the one that fires the event. And on the other hand, we have one or multiple consumers. Now, what happens is that on the message bus, we have channels. Channels are message types, like pretty much like objects. You have like an event to say, I have a robot event. I maybe have a Windows closed event. These are the different types of channels that you can have. And the way this works, the subscriber model works, is that first event consumers have to subscribe to a given channel. Once they're subscribed to a given channel, they can receive messages. And so then the publisher or the event producer publishes a message to this channel, and everybody who was subscribed to this channel gets the message. So this is turning into broadcast mode, basically, fan out, so that all event consumers get the message. Now, all of those streaming APIs do use this kind of publisher-subscriber model, but there are certain differences in terms of data structure, the way these messages are published, and the way the clients are subscribing. And I'm going to go over these differences right now. I will start with the data structure. So for the data structure, some of these APIs are very structured, others are loosely structured. So if you take, for example, the push topic is actually defined by a SOQL query, so that's a database request with fields that are written in this database request. And every time the result of this request changes, we are firing an event with the fields that were in the SOQL query. So this is structured, and the structure of this message is dependent on the query, on the object on which you're querying. So you cannot change those fields unless you change the object itself. Now, generic, however, is loosely typed. So that's just a big unstructured text. You can actually use it to send JSON or whatever text you want. It's limited to 2,000 characters. So it's up to you to structure it the way you want. Now, there is no condition that two different messages from the same channel are the same. So you can write whatever you want. You can change the format from one event to the other. This can actually lead to some errors. And this is why we introduce platform events to turn generic messages into more structured data. So with platform events, we're now imposing a custom structure. So we have typed fields, pretty much like you could have a custom record, custom object. So you can define a set of custom fields. Now, these fields can be typed, but the typing is depend on what the underlying protocol supports. So it's not like a full custom object. We're limited to text, date, string, and booleans, basically. Then finally, we have change data capture. So change data capture is more or less the new push topic. Change data capture is registered based on an object, so we're actually tied to the object fields. And each time an object changes, we are getting automatically change data capture events. So the fields of the object define the change data capture format. Talking about publication. So some of these events can be manually triggered, others are automatically triggered. And this is also an important difference. So for example, push topic is automatically triggered. Depending on the result of the SOQL query, if it's changed, it's automatically pushed. Then we have the REST API for the generic events. These are only manually triggered by the REST API on the platform. For platform events, that's the best of both worlds. We can use declarative code to automatically publish events, or we can use code to actually publish manually. And for change data capture, it's only fully automated. Finally, for subscription, if you look at the legacy events, they are only code-enabled. So you have to manually code the way you send those events. The way you code the way you're subscribing to those events. And this is not something that is provided on the platform. You have to write your own client to do that. Now, on the platform events and change data capture side of things, you have the option to either use declarative things or to use code. And I'm going to go more in details about what are the options in there. So for now, I'm done talking about push topic and generic. All the rest of the presentation is going to focus mainly on platform events and change data capture, since this is the future of streaming APIs. So let's have a look now at what are the options in terms of publisher and subscriber model. I'm going to do another diagram that is pretty much consistent with the one you just saw earlier. We have the enterprise messaging bus in the middle. On one end, we have publishers, and on the other end, we have subscribers. Publishers or subscribers can be either external applications that are outside of the platform, or they can be the Salesforce platform itself. So you can pretty much publish events on the platform, from the platform, and receive them on the platform. It doesn't need to go out to an external app. Or you can also use only external apps to send and receive events, and you can mix and match both of these options. Now let me go into the different options for publication. If you're running on the Salesforce platform, you can either use Apex code to publish a platform event, or you can use also declarative tools such as the process builder or flows. So this is the declarative options to publish platform events or change data capture events. Then, if you are working outside of the platform, or even in the platform, you could also do that. You can use the Salesforce platform APIs. So you can use SOAP, REST, or bulk to push those messages. And you would create a platform event in the same way as you would call a REST API to create a custom event. It's exactly the same syntax. It's /s_object, etc., and you can create a new record with the fields you want. Now, on the subscriber end, two options. If you're on the Salesforce platform, you can use a simple Apex trigger, exactly the same way you would create a trigger on a custom object or one of these standard objects. And you can also use process builder again or flow if you are interested into a declarative option to receive those events. Now, if you are running an external application, you'll have to use code. And here I'm giving you the technical detail. You have to use the bio protocol. This is the protocol that supports this event. And I've listed a couple of libraries that implement this protocol. This is only if you want to implement it yourself. The default one that we actually use is Comedy. That's the one that supports the live streaming of events within the platform, but you can use the other ones there. And then there's a last option there. If you want to subscribe to platform events, for example, within the user interface of a platform, like if you're building, for example, a custom Lightning web component or a custom Lightning component, you can receive those events if you want to have, like, for example, live notifications or instant notifications. In that case, you could use the buyer protocol, but I'm going to tell you that you shouldn't. You should use the EMP API component. So we've built a component that wraps the client for the streaming API within an easy-to-use component. And this is what I'm going to talk about. So let's say you want to receive live notifications or live events on a web page. So you're talking about Lightning page. Whether this is a Lightning web component or Lightning page doesn't matter. You're basically running code inside your browser. And on the other hand, there's the server or the Salesforce platform, which has the messaging bus. So on your page, you have a set of Lightning components. You have the ones that are internal, for example, the header of your org, maybe the surrounding components. And then maybe you have a couple of custom components, and you want to actually register to those streaming events within that page. So how do you do that? Well, you have to receive events from the Comedy server, which is actually the one that handles the network traffic between your server and your client. But you cannot actually directly communicate to the server, because in that case, you would have 4 connections open on the same page. So the way we do that is actually we share for you a component that's called the EMP API, or Enterprise Messaging Platform API, that actually does all the handling of the network for you. So that it actually regroups all the requests and all the server requests into one single shared connection. This is the way we deal with notifications, because not only your custom components can receive notifications, but the platform itself also is using this Comedy connection to actually push updates to the different clients. So that is the way to go. You want to use this EMP API component to handle the connections. It's way simpler, and so it scales in terms of performance. Now, that's it for what is the current state. I'm going to talk about what is new in summer 19, what are the new things that we can do. First of all, the EMP API component has been released now on Lightning Web Component. Before that, it was only an Aura component, but now we have a new version that's going to be available as a Lightning Web component, so you can do exactly the same thing as with Aura. So you can receive those events in your user interfaces. And then there are 2 sets of updates for platform events and updates for change data capture, and I will go over them a bit more in detail. For platform events, we've introduced several options. The first one is actually the publish behavior. The problem with platform events in the past is that this is something that is absolutely asynchronous. That means that as soon as your code gets to the point where it's calling a publish on the platform event, the event is published. But if you have a bit of logic after that, and for example, you have an exception, if you are making, like if you have an Apex error, the event is already published, and it's not part of the Apex transaction. So we cannot roll back, and we cannot cancel the event. So that was forcing developers to actually have a very rigid way of handling the code, because you would only fire the event once you were done with the rest of the Apex processing, because you wanted to make sure that the Apex would run first, and then you would fire the event. With this publish behavior option, you have the option to cover your code first and then publish after the commit, once the Apex transaction is over. Then there are a couple of more useful things. When you do batch processing of events, you now have a resume checkpoint. The problem was before, the way the triggers were handling process events was that they were handling batches of 2,000 events. But if you were doing a bit of Apex processing, you cannot process 2,000 events because you're limited to 200 SOCO queries. And same thing, there's another thing about errors. When you were having errors in asynchronous processing, you would not get updates about errors. So now we have another platform event that actually publishes publish errors. So it's an event that publishes about publish errors. It's a bit meta, but that is very convenient when you have bulk publication. Then on the change data side of things, we now have triggers for change data capture. Before that, it was only possible to have triggers on platform events. Now we have the same capability for change data capture. Now, some of you will think that it's actually almost the same thing as a trigger on the actual object itself. But what is the advantage of change data capture is that this happens outside of the transaction. So if you want to make changes to the object. You can do that outside of the transaction that actually modify the object, because change data capture happens after you change a record. You can actually have a second chance to modify the record after you actually written that update change to the database. Another thing that is interesting is that you can now group change data capture events. So instead of having a single channel for like, I don't say like an account change, you can now group several object changes into one single stream of events. So you can work with changes about an account, its contacts, and maybe its leads. You can group all of that into a single channel, so you only subscribe to one event, and you get updates about these 3 different object types. And finally, there are a few new standard objects that have been added to change data capture, things like contracts and campaigns, but this is a very minor thing. I won't go more in detail on that one. Now that we've seen the different types of event, I'm going to use the next 5 minutes I have to show you a bit of a demo. Oops, went a bit too fast here. So now I'm going to use the 2 monitors, and I'm going to show you how we can use a bit of software to actually monitor those streaming APIs. It turns out that I actually published on the App Exchange a tool called the Streaming Monitor, which allows you to subscribe to all types of platform events. And with that, you can actually get notification about different types of events. There we go. So I'm going to show you how you can subscribe to a demo event, custom platform event, with just a simple field message. And I'm going to use my other monitor here to subscribe to the event. Here I have a subscribe all button that will actually look for all the event types that are possible. So this covers the generic, PushTopic, all the streaming APIs basically, and change data capture. And now you can see that we're subscribed to this event. Now, if I go over the second monitor here, and if I actually publish this code here by executing this anonymous Apex, I'm going to fire an event, and you can see it's appearing on the other end, on the other platform. Now, I could do that also with a device. I could do that outside of the platform. And here we can see detail of the event with the messages field. Now, this is pretty convenient. But what gets even more interesting is that, for example, if I refresh the page, of course, I will lose the event because the event is not saved into the database. But I can actually use this user interface to leverage the replay capability of the streaming API by replaying all past events. So if I change this to replay past events and I'm subscribed, I will automatically get all the past events that were sent. Here you can see I did some tests before the demo, and I got some history there. I played yesterday a couple of events to do my tests. And this is what you can do with the streaming APIs. You can replay them, and you can subscribe only to the latest one. All of these messages have actually a unique identifier here that's called the replay ID. So that's something you can use when you get events and you're missing a couple. You can actually start from a given replay ID, and these numbers keeps on increasing, so you can replay from a given point in time. Now, you can only replay to a certain point in time. The limit is actually 48 hours, and you cannot go beyond that because the events are not saved in the database. That's it for my demo. I will now finish the presentation, go back to the slides. So what did we see today? We saw a couple of use cases for the streaming APIs. We saw that they're good for integration, be it for software integration or device integration. And we saw also that they're good for real-time notifications inside your user interfaces. I demonstrate how you can use the platform events or change data capture, and that is without code, be it declarative tooling like Lightning Flow or Process Builder, or how you can use them with code such as Apex, the REST API, Bulk API, or SOAP APIs. Now, with that, I will leave you with a couple of resources that you can get your hands on. There are a couple of thread projects that you can use to learn about the change data capture events and platform events. The 2 first ones are modules, so they cover most of the theoretical content. And the second one is actually, the third one, sorry, is actually a fun little project, sorry, that I actually wrote that teaches you how to do platform events, how you can build a small application with platform events. And on the side, I'm also sharing the streaming monitor that I just demonstrated during my demo. This is very useful when you want to debug platform events. It's open source, so you can either install it very easily from the App Exchange, or you can also download it from GitHub and deploy it with Salesforce DX if you want. Thank you, and if you want to see that in action, yeah, you can also jump upstairs and see the Robotics Bridge demo, all of these streaming events that animate all those robots. Thank you very much. I'll be taking questions.